So let us, after getting the formula of work done, which is equal to the torque times the angular displacement. Now let us see an example related with what we tried to see, my dear students. So we say that our example number 4.10 give us the overview about the formula of the work done. How we get the work done. This is how it is trying to explain for us. So our question is that calculate the work done by the torque of 60 Newton meter if it rotates a wheel through the 4 revolution arm. So as we try to observe our example here, that imagine we have the wheel, and that wheel try to rotate on it is an axis when the tangential force is applied. The torque that is formed when the torque that causes the ring the wheel to proceed rotating, we have been given, which is equal to 60 Newton meter, and also the angular velocity means this is the angular acceleration that we have been given the angular displacement. The angular displacement means that when the wheel trying to rotate, it forms the angular displacement which is for a revolution. It means kwamba alijaribu kuzunguka mara 4, ndio kitu ambacho kimeelezewa hapa. Kwa tulipo apply the torque ile when we was applied the torque, now we observed that this wheel rotating trying to rotate 4 times. It means kwamba ilijaribu kuzunguka ni mara 4 for a revolution, as we observe on our question here. Now how can we get the work done? This is what we have been asked into our equation here. The first step is to summarize the data that we have on our question here. But on our question, my dear student, we have the torque. It means the force that is applied, the torque, which is equal to 60 Newton meter. And also we have the angular displacement, which is equal to 4 revolutions, as we observe here. Now, how can we get the work done? Before we solve this question, we were supposed to understand this key terms, work done by the torque, the definition of the work done by the torque. So the work done by the torque, my dear student, this is obtained by taking the force that the tangential force that exert on the wheel. Then we multiply by the distance, the arc distance that could appear when the wheel trying to rotate. But we say that the distance of the arc distance of when that is formed when the wheel trying to rotate might be equal to r theta. Kwa tutamwambia sasa, kumbe tuweze kupata huyu work done ni sawasawa na force yule tangential force, then we multiply by r theta. But fr we know ni sawasawa because fr hatuna kwenye swali letu, hatuna force wala hatuna r. Kwa kama hatuna r, lazima tumuondoe ile force times r, to substitute ni sawasawa na torque kama tulivyo ambiwa hapa kwenye swali letu. So now let us say that if we omit fr and substitute equals to torque, we could say work done must be equal to torque times theta, as we see this theta represent the angular accelerations, the angular displacement. But we have been given the torque. We have been given the torque which is equal to 60 Newton, and also the angular displacement which is equal to 4 revolution. Now, how can we get this torque? How can we get this work done? First of all, we are supposed to convert the revolution to radian, as we know. Kwa step ya kwanza tujaribu ku convert ile tuliyopewa hii revolution, the revolution that we have into the radian. As we know that 1 revolution is equal to 4 pi, kama tunapojua tunapokuwa tunabadilisha. Kama 1 revolution ni sawa na 4 pi, na sawa na 2 pi. Je, wale 4 revolution watakuwa na radian kiasi gani? Ndio kitu ambacho tunataka tuweze kukifanya. Kwa hiyo we are supposed to record that when we convert from 1 revolution equals to 2 pi radian. Now there are how many radian if we have for 4 revolution. Kwa tukisha convert pale tuka cross multiplication tutakuja tutapata kumbe for revolution times this 2 pi radian divided by revolution ni sawa na 8 radian. As we know that here below we have the revolution over revolution, and also at the top we have a revolution. Now we could cancel this revolution, and we should remain by 4 times 2 pi. Sasa yule 4 times 2 pi ndio anatuletea sawa na 8 pi times hii radian yetu ambayo tunajaribu kuiobserve hapa. So after this one, now let us recall now calculate the work done. Let us recall our formula that work done is sawa na torque times the angular times the angular displacement. Kwa tukirecall pale tutakuja tutapata sasa instead of writing this torque here, instead of writing this torque, we are supposed to place the value that we have been given into our equation. And also instead of writing the angular velocity here, the angular, it means the angular acceleration, the angular displacement, we are supposed to the value that we have tried to convert it into the radian. Kwa ndo kitu ambacho tutaenda kukifanya kama alivyojaribishia hapa. Amesubstitute palipo na torque ni sawa na 8 ni sawa na 6 newton meter, and also palipo na 8 pi, palipo na hii it means palipo na angular displacement amejaribu kusubstitute ni sawa na 8 radian. So after substituting here, we are supposed to take our calculator, my dear student, so as to solve our question as we observe. Kwa nacho kitakiwa sasa tuchukue calculator zetu. Baada ya kuchukua calculator tujaribu kusolve swali letu kama tulivyoulizwa hapa. Kwa tukisha substitute pale tutakuja kupata kumbe W must be equals to 150.8 joules. Kwa ndo kitu ambacho tutakuja kukipata hapa. If we take this 6 newton meter and times it by 80 pi radian, we should get by 150.8. You have to take your calculator and write this 6. Achana na hizi sayunti kwanza. Ukiandika 6 then weka alama ya kuzidisha, alafu weka 8, alafu nenda kwenye shift uangalie pale chini kuna pi, ile pi itajitokeza pale. Ndio utapata ambao ni sawa na 3.14 au ni sawa na 22 ya 7. Kwa hiyo tutaweza kupata ile jibu letu. So after getting this one, we are supposed to conclude by saying that the work done by the torque is approximately at 150.8 joule. Kwa sasa tutawaambia kumbe ili tuweze kupata work done by the torque ni sawa na 150.8 joule. Ndo value yetu ambao tulikuwa tumeulizwa hapa. So after this one, my dear student, we should have the task, and our task would be this one. That first of all, can you define the work done by the torque? And after there, the second task is that what is the formula of obtaining the work done? Or you will be asked that prove that the work done must be equals to torque times the angular velocity. This is some task that you'll be asked here. So by saying that, my dear student, this is the end of our session here. Now I would like to welcome you again for another session. I wish you all the best. Have a nice moment.